All right, happy Friday to you at home or in class. Friday the 29th, we basically take a little break, sort of, from learning pre-cal because the next 2 weeks are AP test, and that's most important. And many of you are taking one or more, and we want you focused on that. And so we ease up on the calculus or the pre-cal to let you focus on your AP test. The hope is that you can complete all of the roller coaster project in class. It's a group project, and you get 2 weeks and a day. It's due Friday, so you should be okay to do it. And then that last week we'll do a little bit of calculus, a little pre-calculus, but that's the whole class. But we'll touch in a little bit of calculus on that last week, have a 50-point test, and then we're pretty much done.
50-point test?
Yeah.
How does that work? It's just half, like...
It's worth half as much. Yeah. All right, so let's talk about the roller coaster project. So the grade isn't worth as much on that last one. The roller coaster project is a full summative grade that if you do what you're supposed to do, you should definitely make an A, and then sort of how creative, how neat, how polished your presentation is, or your video is, your slides are, that'll take you from a 90 to 100 kind of a thing. All right, let me pause and pass out the... All right, so the roller coaster. A little bit of, fake background to try to make it a real life thing. An established company, the Thrill Ride Roller Coaster Company, has asked your group to help design a roller coaster track. The Thrill Ride Company wants to build a roller coaster subject to a set of constraints. You are told that the company has several engineers who could design a blueprint and build the track if only they knew the functions whose graph would define the desired curve of the track. Your task is to define a piecewise function. All right, I got my answer. That is over the interval 0 to 15, whose graph satisfies the following constraints for the roller coaster track. The entrance on the track is at 0, 10. So this is important. These are the points you have to meet. So the entrance, the starting point, is 0, 10. The exit is 15, 0. There are at least 2 local extreme values. A minimum at 4, 2, and a maximum at 8, 8. I'm out of colors. You may extend your exit if you would like to, but the final point must still have a y-coordinate of 0. So you start at 0, 10, you got to go through 4, 2, and 8, 8, and then you got to end out here somewhere. Whoops, put that where you can see it. And so you figure out exactly what you want to what your coaster to look like as long as it hits those points. And 4, 2 is a minimum, so it's got to look like that. 8, 8 is a maximum, so it's got to look like that. The slope of the curve at the entrance and exit points must be 0 in order to facilitate getting on and off the roller coaster. So you can't start, on a downhill run. You got to start at least instantaneously. You got to start at 0 slope, and then it'll go down. And same thing at the end. You end with the 0 slope so that people can get off the roller coaster. The curve must be smooth, meaning the piecewise function must be knit together without any kinks. So, obviously that is not a roller coaster right there. So it's got to be continuous, but it can't have any kinks like that. That doesn't work as a roller coaster. It's got to be smooth. A hint on that is if you connect the pieces at maxes or mins, it makes the connection a lot easier and a lot smoother. If you try to connect it midway through a sine or cosine curve, it's almost never going to be exact. I'll be able to zoom in and see that there's a kink there. So it's much easier to make the connections at the top and the bottom in order to something like that. So that's 3 different functions. But again, if you match them at the peak or the valley, you won't have to really worry about the kink problem. It's a lot easier to do that way. For continued customer interest, maintenance, and future customization, you must build the roller coaster track out of pieces, piecewise function. Based on the given constraints, you must also decide how many functions you will knit together to build the track. You must use a minimum of 3 functions to build the coaster. Your presentation must include a minimum of 3 slides. And you're not going to like give the presentation. It's like you're going to submit the PowerPoint or the Google Slides to me. Presentation video, so you need to have a video in there that's between 1 and 2 minutes long. Okay, that's not a long video. I don't need you to walk through every single thing about your roller coaster because that would take longer than 2 minutes.
So you want us to build it and make a slideshow?
Well, when we say build it, we don't mean like physically build anything.
Oh.
You can build it in Desmos if you like, or just on your calculator or wherever. But Desmos is probably the easiest. The easiest to maneuver. On the video, let me talk about the video, and then I'll talk about the equations, and then we'll talk about groups and stuff. For the video, here's some of the options you could do. You could explain one of the functions. Right, like all the functions are going to look like, right? Remember when we walked through what all of those pieces were? And so take one of your functions. You'll have at least 3, but take one of them and explain that there's a 7 there. That's the amplitude. B is equal to 2. That controls the period, which makes the period whatever. The phase shift is 12. That moves it over to the right 12 or left 12 or whatever. So that's one thing you can do. You can discuss what was hard or easy about the project. We had a hard time figuring out how to make it hit this particular point, or we had a hard time figuring out a good theme. You can explain your theme. And sort of sell the ride, like why it's going to be fun. You don't have to do all of those. It's only 1 to 2 minutes long. So again, I don't want 5 minutes on each of those things. Maximum 2 minutes. So quick, little short video of you doing a little bit of math explanation, but mostly fun stuff. On the equations, it's probably best to not just play guess and check on Desmos. It's probably best to go back and review graphing trig functions, graphing sines and cosines. You may think it's quicker, like I'll just guess and check. It's quicker to get started that way, but in the long run it takes a lot longer. So you want to kind of go back, spend a few minutes reminding yourself what each of those pieces do, and then play with Desmos. And once you have a better understanding of what all those do, then it will be really easy for you to hit, whatever points you're trying to hit. So my suggestion is don't just jump on Desmos and start typing random stuff in and trying to make it work. That probably will take you longer, and you probably won't be right if you do it that way. Desmos.com is an online graphing tool. It's pretty easy to use, and I'd recommend using that to figure out your equations. I'm not going to walk through the rubric. It's on the back. I suggest you walk through it so you know what you're doing. So most importantly, maybe you're thinking group size 1 to 3. So you can fly solo if you want to, but maximum of 3. 4 people is too many to do this particular project. If there's a group of 4 of you that want to work together, well then split up 2 and 2, and you can all work together if you want to, but I need 2 projects. Max group size of 3. And again, that's good because if you get 4, then you can split into 2 and 2. If you know that you're going to be out a bunch of days in the next 2 weeks for AP testing or for whatever reason, then maybe you want to go solo because you can't make it work with a team. I kind of leave that up to you. So Group size is your call. And then lastly, it's due on the 13th, Friday the 13th. That's fun to say. But the good news is you've got 2 full weeks to work on this. All right, so it shouldn't be a problem. This should give you all a 90, 95, 100, somewhere in there. Boost that grade back up heading into the last little bit of the school year. I did want to show you a few examples of good ones and not so good ones. So this is from Miss Morris, obviously her second period. I think this was last year. So there's a Tron. All 3 of those guys are in my calculus class this year. Tron roller coaster, little explanation. They included a link to their video on their slide. That's really good. You can embed it if you want to kind of get fancy. They just did the link, which is also fine. So here's the overall picture. And I can tell from that picture that they use Desmos. It says it right there. So there's their equation and the domain for each one. So from 0 to 4, they did this graph. From 4 to 5, they did this graph. But there's a mistake. There's a kink right there. That is not a smooth transition. So that they would lose points for that. My guess is that's probably not a smooth transition either. That one's not either. That one's not either. I don't know if they have any smooth transitions. Again, if you make your transitions at the top or at the bottom, it makes it a lot easier than trying to match up exactly the slope. So make them at the top or the bottom. Make your life easier. There's the rest of their graphs. It's kind of color-coded. Cool Tron background.
Are you going to have your Chromebook card?
I will work on that. Because that's a good question. Cars. Oh, I have 2 of those people. They're doing theirs. I kind of don't like this. I'd kind of like to see an overall picture and then break it down. So they just did the first piece on their first slide, second piece on the second slide. Maybe they put it together at the end. Yeah, there it is. That's probably not a kink. That's probably a kink right there. So is that. That's my guess. That might be okay. And then there's a link to their YouTube video where they explain or whatever. Oh, that's a nice graphic there. The Winter Mountain Train. I'm glad I showed this one. You could go underneath the ground. That's fine. There's a roller coaster at the Dallas Six Flags that goes like in the ground. That's fine. There's probably some explanation of that. Black section is used for the underground portion of the ride, where they're taken through a cavern. It's also used to accelerate the roller coaster. So get creative with it. Have some fun with it. There they are. That's probably their video. Pink. So their theme is just the color pink, I guess. Oh, the Starburst section. The money section. I don't understand how money goes with pink, but Barbie section. Here's some of my students from last year. The spooky roller coaster. There it is. They extended beyond 15.0, but it still landed at 0. This looks like a pretty good one. There's a minimum at 4.2, a maximum at 8.8. They did a whole bunch of other stuff, and they landed back at the ground. Let's see. Let's watch one of these videos. Maybe. There we go.
So the blue line that we kind of have trouble with was this blue line here. You get to have both the required points, which is 4.2, and no, not 4.2, but 4. 2.8. So we had to find the period that would fit within the sequence, which ended up being this decimal here, which is 0.785398, which is found using the 2 pi over d multiplied c equation, and then we have to find the amplitude by figuring out the height between the 2 points, and then by using a cube to get that.
Because at that point we hit like all of our requirements, we just kind of had fun, like making all these lines. Like as you can see here, the ride does go underground, which is pretty cool. It's 2 feet deep, it's into the basement, it's 50 into the cloud. It's scary. And then afterwards you can kind of move around and then you finish.
So you get the idea. It's simple. It's not, the video is not a major production. You could tell, that most of my videos, the students recorded them either in the room or out there, kind of just with their phone, and that's fine. I'm not looking for professional. This one was kind of silly. They thought they would use my name because, of course, that's funny. So Roller Rex with my face stretched and superimposed on a dinosaur. Again on the dinosaur. But there's their equations and where they used each equations. And there's the video. Again, you can see that's right back there at the stairs. But this one was a little more creative than the last one. Oops, we don't need to watch another one. So I think you get the idea. Again, Desmos is a really nice place to go to find, let's see, you don't need to do any of this stuff other than give me a graphing calculator. And then you type in y equals 2 sine of pi. I just typed pi and it put it in there. X minus 3. And I can do that. Forget how to do the, here we go. 0 is less than x is less than 4. Oops. Now, why isn't that working? Use parentheses around the argument of sine. Oh, at least it tells me what I'm doing wrong. There we go. And the curly Q, or the little fancy brackets, is how you limit the function, how you set the domain. So it graphed that sine function between 0 and 4. And so kind of start there, and then, well, it's got to be up at 0, 10, so maybe I need to go up 10. There it is. Except that's not starting at level ground, so I'd have to play around with this some more. In fact, cosine might be a better choice, because cosine starts at a maximum. But I want to flip it over. There we go. But then I need to move it down. So, there we go. Now I'm starting at 0, 10, and I'm starting flat. I'm ready to go. That's definitely not going through 4, 2, so I'd have to play around with some others. But Desmos is a nice way to do that. And it automatically assigns a different color, I think, when you start a different graph. Yeah, so it's easy to tell what's what. We'll do that one from 4 to 4 is less than x is less than 7. Except I need to be up at 10, so y equals 10. There we go. So, you get the idea. Play with Desmos to come up with your functions and your domain restrictions. So, do 2 weeks from today, group size 1 to 3. I will work on getting some computers in here so you can play with it. Questions? Okay, so you're kind of on your own. If you're not working on this, I will be hounding you to work on it while you're in here until you get it finished.